Welcome to Lil Life Facts.
Today, we're unpacking a stack of research on the human ear. We need to debunk a massive myth right away.
The idea that ears never stop growing.
Exactly. I see this cited constantly to explain why older people have larger ears, but the cellular biology just doesn't back that up.
No, it's not growth. Not in the typical sense. If your ear cartilage was actually, dividing and growing for 80 years, your ears would be enormous. What you're actually seeing is a long battle with gravity. Over decades, the collagen breaks down, the elasticity fails, and the ear just stretches. It's sagging, not growing.
Which is so interesting because while the outside is getting stretched by gravity, the internal machinery is microscopic.
Oh, totally.
I was looking at the dimensions of the ossicles, the malleus, incarcus, and stapes.
The hammer, anvil, and stirrup.
Yeah, and you could literally fit all three of them on the face of a single penny.
And the stapes, the stirrup, is the size of a grain of rice. Yet these tiny bones have to vibrate with perfect precision.
Wow.
That's why they're housed inside the temporal bone.
Which the research notes is the hardest bone in the entire human body. It's essentially a biological bank vault designed to protect that little grain of rice.
It has to be that secure. The sensors inside are incredibly delicate. And we aren't just talking about hearing sensors, we're talking about the rocks in your head.
The otoconia. This was one of the strangest details for me. These are literal calcium carbonate crystals sitting on top of hair cells in the inner ear.
Exactly. It's a pure physics system. When you accelerate in a car or tilt your head, gravity pulls those crystals.
Which then bends the hairs.
Right. And that signal tells your brain exactly where you are in 3D space.
So when people suffer from vertigo, is that just a mechanical failure of this system?
Yeah, it often is, yeah. If those crystals detach and roll into the wrong canal, your brain gets conflicting data. It thinks you're spinning even when you're standing still.
That is just wild. And there's another bizarre connection here between the ear and taste.
Oh, the chorda tympani nerve.
Yes. It carries taste signals from the tongue, but it takes this weird detour right through the middle ear.
It runs directly across the eardrum. It's a bit of a quirk in human anatomy. Because of that, an ear infection or surgery can physically compress that nerve.
So you could get a metallic taste in your mouth from an ear infection.
A metallic taste, or you might even lose the ability to taste sweet or sour on one side of your tongue, all from an issue in your ear.
It really highlights how interconnected the hardware is. Okay, let's talk maintenance. The engineering solution for keeping the system clean is fascinating. Turns out, earwax isn't just dirt.
Not at all. And the ear canal is basically a self-cleaning oven.
Or more like a conveyor belt, right. The skin inside your ear canal grows in a spiral pattern moving from the eardrum outward.
And we power that conveyor belt with our jaws. Every time we chew or talk, that motion mechanically pushes the wax and debris out.
Which is exactly why you shouldn't use cotton swabs. You're just fighting the conveyor belt.
Precisely. And that wax is actually a protective shield. It's antibacterial and waterproof.
Speaking of shields, we also have a built-in volume limiter. The research describes the acoustic reflex.
Right, with the tensor tympani and stapedius muscles, the smallest muscles in the body.
They contract during loud noises.
It's an instant dampening system. Those muscles stiffen the bone chain to reduce vibration and protect the inner ear. It's not fast enough for something like a gunshot, but for sustained loud noise.
A concert or something.
Perfect example. It's a crucial defense mechanism.
So we have to wrap this up by looking at the processor. Because ultimately, the ear is the hardware, but the brain is the software. And it seems we have a kind of dual core setup.
Yes, the concept of lateralization.
Where the left and right ears aren't doing the exact same job.
Exactly. The signals cross over, so the right ear feeds the left brain hemisphere, which is generally better at the logic and rhythm of speech.
Okay.
The left ear, feeding the right hemisphere, is often more tuned into things like music, emotion, and tone.
And this whole processor is running 247. Even when we sleep, the ears are on.
They never turn off. Your brain just acts as a filter. It ignores the white noise of, say, the air conditioner.
But it wakes you up for important sounds.
Instantly, for significant sounds, like glass breaking or your name being called.
So we're walking around with a gravity-sensing, self-cleaning, noise-canceling machine that runs a background security program while we sleep.
And helps you taste your dinner.
Before we go, there is one final detail about identity. Ear prints.
Yes, just like fingerprints, the ridges and folds of your outer ear are unique to you. tech companies are even testing using your ear canal shape as a biometric password.
That's incredible. So here's a final thought for you. Next time your phone rings, notice which ear you instinctively hold it up to. Are you looking for the logic of the call with your right ear or the emotional vibe with your left? Turns out there's a lot more hardware involved in that choice than you realized. Thanks for listening.
Thanks for watching. Like, comment, and subscribe for more fun facts. Click that red button to join us.